right, so today is pretty much a review of yesterday with the addition of one little piece. So you'll see at the beginning that you're like, okay, this is nothing new from yesterday. And you're right, the beginning is nothing new than yesterday. Here's what's happening kind of the rest of this week. Today we're going to do 6-6 day 2. Tomorrow's a late start. Have your homework done, come in. We're going to go over that homework, answer any questions, make sure we're all good. If we have a lot of time, I'll start the notes over 6-6 day 3. If not, but probably not, we'll just save it for Thursday, and then we'll do our notes on Thursday, and then you have a worksheet for Thursday night over 6-6. Then on Friday, we have 6-7. Do you guys remember how we go to stat, calc? We put the list in, and then we went to stat, calc, and then we did linear regression, and then we learned quadratic, cubic, and quartic. Do you remember doing those? Yeah. Well, if you keep going, notice you have natural log regression and exponential regression. So the process of what we've been doing with all our other regressions is exactly the same. It's just now we have log regression or exponential regression. So that'll be our lesson on Friday. Then next week on Monday, we will have our practice test for homework. We will go over that practice test on Tuesday, and we will have our test over chapter 6 next Wednesday. So those of you who I know are going away, we'll talk about that and when we're gonna take that, probably when you get back sometime. But that is next Tuesday and Wednesday. You go over the practice test Tuesday, test on Wednesday. Then we roll into chapter 7. I will tell you. And then the end of the 9 weeks is next week too, which is crazy. Then we go into chapter 7, and I will tell you, just because I know some of you like to plan, we are going to have a quiz. It just fell this way. We're having a quiz the day before spring break. So that Friday of spring break is our quiz over 7-1 to 7-3. Okay? So I kind of, on my way home yesterday, did a bunch of planning, and that's where it fell. All right, so let's go ahead. Review what Coach Mattingly taught you yesterday. There are 3 ways you can solve a log or exponential equation. Who can give me one? Who can give me one?
Same base.
Make the same base. Make them the same base. What else can we do?
Take the log of both.
Take the log of both sides. What else can we do? Rewrite it. So if it's in exponential form, swoop it to log form. If it's in log form, swoop it to exponential form. Good. Now, I'm sure Mr. Coach Mattingly and I talked about this, and this is day 1. These are the notes you had yesterday, aren't they? I got to get the other one. I know we talked about this yesterday, and Coach Mattingly and I talked about this, and he said his favorite way is to take the log of both sides. Is that what he said? Yeah, and it's not mine, but it doesn't matter. Like I showed you, I don't know if he showed you in the first example. Did he show you all 3 ways? Yeah. Good. Okay. So it doesn't matter. You can do it any way, and you can get the same answer. And that sometimes is a reason you guys don't like this, because you're like, well, I did it this way. That's fine, as long as we get the same answer. Okay, so you can do it any of those 3 ways. So let's go ahead and take a look at this first one. Okay, let me get the sticks today. Oh. What do you guys want to do? Who's my caller here? What do you want to do on this one? Oh, she's not here. He's not here. Ty and McKenna. Kaden, what do you want to do? Into what?
-2 squared -2.
How could you do that, though? Think about this one. If you make this 9 to the -2, does this equal this? Do you see how you did it equal? You crossed it. Can't do that. And that's a common error on same bases. You need to make the bases, you need to make this side equal and this side equal. So you're kind of right. I would do same bases. But what base are you going to turn them into? Base what? Base 9. What is 81 equal to? 9 squared. So do you see how I did not change the value of this side? What is 1/9 equal to as a base of 9? It's equal to 9 to the what? 9 to the what equals 1/9? There you go, -1. Do you see how now I have not changed the value of each side? What she did is a very common mistake. People cross and they make this base equal to this over here, and that's not correct. So keep the left side equal, keep the right side equal. So now she has same bases. So now what can you say here? 9 to the 2x is equal to what?
9 to the
-1x minus 3, because again, she said she's got to distribute. And now, since you have 9 to the 2x equals 9 to the -x minus 3, what can you say are equal?
2x equals -x minus 3.
And this is a linear equation, so what are you going to do?
Add 1x.
Add 1x, and when you do, what do you get?
3x equals -3.
And what do you do to solve it?
Divide by 3.
And when you divide by 3, what do you get for x?
-1.
Now, we should check, and today in a few minutes, you'll see why. When we check 81 to the -1 equals 1/9 to the -1 plus 3. Well, let's work on the right side first. What is -1 plus 3? To the 2, and that's 1/9 times 1/9. What is 1/9 times 1/9? 1 over what? 81. What's 81 to the -1? 1 over 81 to the first. Did it work? Yes. Okay. Questions on A? Alrighty. Let's take a look then at B. What do you want to do to solve B? Jared.
Divide by 3.
Oh, divide by 3?
Or deep.
Careful, if you divide by 3, then you just got an exponent hanging up there equal half. What? Can't do that. Okay, so we're not going to divide by 3. So what are we going to do?
I'm not sure.
Okay, our 3 choices, write them in the same base. Can you write them as the same base?
No.
Take the log of both sides. We could do that. Or change forms. Swoop. Make it from exponential form to log or log to exponential. So now that you've talked about those, what do you want to do?
Take the logarithm.
Of both sides?
Yeah.
Okay, so when you do, how do you write this?
Log 3 x
To the x equals,
8
well, you said
equals-
take the
equals-
log.
equals log 8.
Okay. Now what do you do with that x?
2. Wait.
What's the rule if you have the x as an exponent? This is not going to be done. But go ahead. What do you do with this?
Move it to the front.
Move it to the front. So you get x times the log of
3.
equals the log of
8.
What are you going to do now?
I don't know.
Okay, try to get x by itself. What are you going to do to get x by itself?
Subtract log.
What's the operation here? What's the operation?
Multiplication.
So what's the opposite of multiply?
Divide.
So you're going to divide both sides by
Log 3.
log of 3. When you do, those cancel. You get x equals. Now we grab our calculator. And we do log of 8. Close your parentheses. Divided by log of 3. And what'd you get?
1.8927.
Okay, so let's go to 2 decimal places when we round on these. So it'd be 1.what?
89.
89. Okay. Now, what did some of the others of you think to do? Change the form. What form is this? Exponential. So let's swoop it into log. How would you guys swoop it into log? Log base of equals math alpha mouth. Or old school calculators, log of 8 divided by log of 3. And do you guys get 1.89? I think that's easier. Okay, but can you take the log of both sides? Yep. Okay. Now when we check this, when I check it, if I use 1.89, I will get approximately 8. If I happen to raise it to that second If I happen to raise it to that second answer, I'll get exactly 8. But if you raise 3 to 1.89, you'll get very close to 8. So we're good. Any questions? All right, next one. Ooh, this one. I will give you this formula. You do not have to memorize this formula, but you need to know what everything stands for. Okay? So your friend is cooking her famous chili. When she takes it off the stove, the temperature is 212 degrees. The room temperature is 75. Cooling rate for chili is 0.051. How long will it take it to cool the chili to a serving temperature of 95 degrees? Okay, so let's fill this in together, everybody. What do we want T to be? 95. That's our final temperature. What is the initial temperature? 212. What's the room temperature? 75. E to the negative. What's the rate? 0.051 T plus the room temperature again, which was, okay. Are you guys okay with plugging that in there? Now we got to solve this ugly formula. What did you guys do first? Subtract 75 and probably subtract 75 in there. I don't know which one you guys were talking about, but let's subtract this 75. What do you get when you subtract 95 minus 75? 20. And what do you get when you subtract this in here? 137. E to the negative 0.051 T. All right, now what are you guys going to do next? We are not in exponential form. You cannot swoop yet. Divide by 137. Divide by 137. I'm just going to leave this fraction. All right, now, this is exponential. So how do you undo this exponential equation? Swoop. So we're going to swoop from the base. Log base E. What is log base E? Natural log of 20 over 137 equals negative 0.051 T. And now the last thing you would do is what? Divide by what? Negative 0.051. So, calculator work. Natural log of 20 divided by 137. I hit enter just to make sure. Then divide by negative 0.051. And what did you guys get? Did you get 37.7? And that would be minutes. All right. Thoughts on that one? So far I haven't taught you anything new from Coach Mattingly yesterday. Are we good? All right. Moving right along. Natural log of 5x plus 2 equals natural log of x plus 10. Jordan, what do I do when I have the natural log of this equal to the natural log of that? She said just set them equal. Guys, these are the ones sometimes are so easy you make hard. If you have the log of this equal to the log of that, this and that are equal. Okay, and now it's linear. So Jordan, what do you want to do to solve this? Subtract x, and when you do, you get what? And now what? Subtract 2, and you get 4x equals, and then x equals 2. Now, I should check this. The natural log of 5 times 2 plus 2, does that equal the natural log of 2 plus 10? Well, what's 5 times 2, everybody? 10 plus 2 is 12. Does that equal the natural log of 12? Yes. So we're good. We're going to see in a few minutes when these don't work. Are we good on A? All right. B. Well, on B, remember our 3 ways. Make them the same base. Can you guys make these the same base? Take the log of both sides. Can you take the log of a log? Swoop. Lucas, what are you going to do? Swoop. From the base. So what are you going to tell me?
3 to the 4th equals 10x times 9.
What is 3 to the 4th?
81.
Now what'd you do?
Add the 9.
Add the 9. What do you get?
90.
Then what'd you do?
Divide by 10.
And you got what?
X equals 9.
Hang on a second. My board jumped on me and it won't go away. Okay, 90 equals 10x. Divide by 10. And he said x equals 9. Now, we should check. Log base 3 of 10 times 9 minus 9. Does that equal 4? What's 10 times 9?
90.
Minus 9. Does the log base 3 of 81 equal 4? Think about this. Now, some of you are using your calculator. You don't need, does 3 to the 4th equal 81?
Yeah.
So did that work? Yes. All right. All right. So that was a complete review of yesterday. So far, how are you guys feeling? You guys said you felt pretty good. Are you feeling okay?
Yes.
All right. Here's the new part. The last 2 problems. Well, again, make them the same base. Can't do that. Take the log of both sides. Don't want to do that. And swoop. Well, I could swoop, but I can't swoop when I have 2 logs on one side. So I need to make them a single logarithm. You know how to make a single logarithm. Condense it. Condense it. Just like you guys practiced last Friday. So, Ethan, what do you do with a plus when you are have logarithms? What do you actually do with this and this?
Don't you just put them together?
How? By what operation?
Multiplication.
Multiplication. He's going to multiply those. Do you remember when you add logarithms, you multiply the arguments? Do you remember that? All right, so let's go ahead and multiply. I mean, if this was 2 and 5, you'd say the log of 10. But we have 2x and x minus 5. So let's distribute. And what do you get when you distribute, Ethan?
2x squared
Uh-huh.
and negative 10x.
Perfect. Okay, now do I have it in single log form? Now I can swoop. What's the invisible base on this one? 10. Remember, if you have just log, it's log base 10. If you have natural log, it's log base E. All right, so now let's go ahead and swoop. When you swoop, you're going to get what?
10 squared equals 2x squared minus 10x.
Okay, so 10 squared equals 2x squared minus 10x. Now it's quadratic. It's not linear anymore, so we can't, do easy math. We got to do a little more work. We're going to either do quadratic formula, complete the square factor. All right, so 10 squared is what?
100
So let's move this 100 over. How would you move this 100 over here?
minus 100.
Minus 100. And when you do, what do you get?
2x squared minus 10x minus 100.
All right, is everybody good so far on what we've done? Now we still got to keep solving this. Any thoughts? Anybody have any ideas what I can do? Is there a GCF? What is it? You have 2 choices. You can factor out the GCF, or because I have an equation, can I just divide everything by 2? You're allowed to do that, or you can pull it out and then it's irrelevant. But if I just divide, I get x squared minus 5x minus what? 50. And now A is 1, life is easy. What question do I ask myself?
What multiplies to 50 and adds -5?
To negative 50
-50.
and adds to...
-5.
So what multiplies to negative 50 that adds to negative 5? What'd you guys come up with? Okay, negative 10, positive 5. Multiply to give me negative 50. Add to give me negative 5. So we're going to write x minus 10 and x plus 5. When I use the zero product property and set each of those equal to 0, what do you guys get? Whoops.
X equals 10. X equals -5.
Okay, so when you set this equal to 0 and this equal to 0, most of you will skip that and just tell me x equals 10 or x equals what?
-5.
Negative 5. Now, we have to be careful here. We have to be careful here, and here's why. All right? I want you guys to think a minute about your log graph. Your log graph, okay, either goes like this or like this, okay? What's the domain of either one of these graphs? X has to be what? X has to be greater than what? 0. Do you guys agree? Has to be great. Okay. Take your calculator. Do the log of -7. Error. Do the natural log of 0. Error. You cannot take the log of anything less than or equal to 0. So now we have to be careful because we need to check. We need to check both of our answers. And if they make the argument negative or 0, it's an extraneous solution. So my first one was 10. When I plug 10 in here, am I good? Basically, guys, what you're looking at are your arguments positive? Yeah, this is the log of 20 plus the log of 5. Does that equal 2? Guys, what do you do with 20 and 5? What would you do? Multiply what's 20 times 5? So this says the log of 100. And now when you swoop, this is what to the what equals what? Does 10 squared equal 100? Okay, that one worked. Again, what are we really looking for? We're looking to make sure that whatever math we do, we have positive numbers, non-negative and non-zero numbers there. So now when I check x equals -5, okay, that's the log of 2 times -5 plus the log of -5 minus 5. Do I have problems here? Here and here. Is that a problem? Can you take the log of -10? No. So that is an extraneous solution, and your only answer is 10. Yes, sir.
When you were second time, why did you like the swoop? So can you just plug in your calculator?
You could plug it in. Yeah, of course you could plug. Yeah, because I don't know. Because I guess so. You could do log of 20 plus log of 5. Is that what you guys did? Log of 20 plus log of 5. Oh, wait a minute. I got to close my parentheses. Log of 20 plus log of 5. Got to close those parentheses. Okay. Other questions? I mean, you could. I just did it in my head. Okay. Anybody else? All right. Let's try another one. Do you guys want to take the log of both sides? No. Do you want to raise each side to a power? No. What are we going to do, Drew? Condense. What do you do with these when you condense with a plus?
Multiply.
Multiply. So you have x plus 12 times x. And now when you multiply, what do you get?
X squared plus 12x.
X squared plus 12x. So that was the condensing part. Put it together. Now what do you want to do? Swoop. See, that's why I really like swoop. If it's a log form, put an exponential. If it's an exponential, put a log. All right, now what do you get when you swoop?
4 to the third equals x squared plus 12x.
Okay, and what is 4 to the third?
64.
And how do you get that over here? You see that? So what is your quadratic?
X squared plus 12x minus 64.
All right. What question are you going to ask yourself? Not here. Landis.
What multiplies to give you negative 64 and adds to give you 12? Positive 16 and negative 4.
There you go. Positive 16 and negative 4. So I get x plus 16, x minus 4. When you solve these, you get what?
X equals negative 16 and x equals positive 4.
Good. Now, guys, just because it's negative doesn't mean it's not. It's an extraneous solution. You have to look at the argument of each log. So I have negative 16 and positive 4. Okay, negative 16, do I have a problem? Can you take the log of negative 16? No. Or when you put in negative 16 plus 4, you get negative 4. How about the log of 4? Does 4 work? So 4 is good. Negative 16 is not good. So what you're checking for with logarithms is that your argument, when you're taking the log of, is a positive number, non-negative. Okay? And I picked problems, like specific problems that I wanted you to do. So that's why it's all scattered, because I liked these ones the best.